Our first speaker is Biliana Pehlivanova, and she's going to talk to us a little bit about the future of LNG supply in the Western Pacific. So with that, Biliana.
Thank you, Zig, and thank you to the GPA for having me here. It's really a pleasure and an honor to be here and witness this very engaging debate. I'm quite interested in witnessing the discussion and the process that everyone here is going through. Please feel free to stand up and get coffee. I fully understand that we all need it at this point. So what I wanted to do today is put into context a little bit the discussion about LNG use. Where does that fit in the global LNG markets? What do the global LNG markets look like? In fact, Guam is looking at LNG in a very interesting time for the global LNG space. This is a market that has been changing rapidly over the last 5 years, and it's about to continue changing just as rapidly in the next several years. If we could go one slide forward. This gives you a perspective, and I'm not sure if you can see all the bars, but of how capacity, global liquefaction capacity has risen since the beginning of the century. It has literally grown more than 45% over the past 5 years. And given the current plans for liquefaction capacity expansions, largely coming from Australia and the US, we're likely to see another 64% growth by the end of this decade. There are very few markets that are growing at this type of pace in this day and age when economic activity isn't exactly booming around the world after the economic stagnation we've had. If we could flip to the next page. Supply is growing rapidly. It's heavily concentrated, and this is important because it puts things into context. When you look at Qatar, that currently provides 33% of the global supply in the case of this year. In terms of capacity, it's a little bit smaller than that, but there are a lot of outages around the world. The key traditional LNG suppliers that had been Indonesia, Malaysia, Egypt, all three of those are actually losing LNG supply volumes because of declining reserves of feedstock gas. And the emerging suppliers is really Qatar, and then with the upcoming construction of new facilities in Australia, and the next in line becoming the US and further on. If you could flip to the next slide, please. At the moment, in terms of liquefaction capacity, Qatar accounts for about 28%, Australia about 8%, and the US actually doesn't export any. We used to have an export facility in Alaska, which at the moment is shut down. There are some talks about restarting it, but it's a very small one in any case. However, the US has a very large number of projects that have, some of which have been permitted, a couple of under construction, and a very other large number is in the various stages of permitting process and planning stages. Once the US has built what we believe will be around 8 billion cubic feet per day of export capacity by the end of this decade, we will be accounting for around 13% of global LNG supply. That is a very large chunk. It will put us very much in the front lines of the global LNG market. Could we flip to the next page? Thank you. This is just to give you a sense for how many projects are out there that are being developed. This is a great time to be a buyer in the LNG market. There is a lot of supply. There is a perception of a lot of supply. And where in the last few years as supply was growing, we saw Qatar adding significant capacity. But after Qatar, whose costs are actually fairly low, the next projects are coming from Australia. And what we've largely seen from the Australian LNG plants is cost overruns and ballooning costs. That's because those are very large integrated projects. A lot of them source gas from coal seam gas, so a lot of technologies that are being developed as these projects are taking shape. With that kind of escalation of cost has come a concern about the price of LNG. And we have seen that over the last few years become a bigger and bigger issue, and more concern arising about the break-even costs of new LNG supply. That has changed drastically with the emergence of the US projects. The projects you're looking at here only include the ones outside of North America, and you can see how largely between 2015 and 17 timeframe, it's almost all Australian volumes. There is also, which is important to highlight for Guam, projects coming online in Papua New Guinea. One smaller one in Indonesia. Malaysia is adding a few ones as well. So there is still a significant supply base that is specific to the Pacific Basin. Could we flip forward? But the US projects are key as well, and that's because they are lowering the cost curve of the global LNG supply chain. With US gas prices significantly decoupled now from oil as a result of the shale revolution, these are the first projects that are introducing a new type of pricing into the global LNG space, one that is linked to a gas hub as opposed to oil prices. At the moment, the DOE has approved 9.5 BCF per day of LNG exports to countries that don't have free trade agreements with the US. There is a whole host of other projects, as you can see, that are in line for approval by the DOE. Out of the ones that the DOE has approved, only the Cheniere project has reached also an approval from FERC. The others are still in various stages of that process, and they need to get FERC permits before they can start construction. So 4 trains are already under construction. The U.S. will start exporting its first cargoes in the 4th quarter of 2015, just next year. And really commercial flows are likely to begin in 2016. And from there on, we believe they're likely to ramp up fairly quickly to about 8 BCF per day by the end of 2020. Could we flip forward? And then Canada also has a lot of liquefaction projects. There's a little bit less, perhaps, talk about Canadian projects because they're a little bit behind the US ones in terms of where they are in their development stages. One of the challenges for Canada is these projects are relying on gas that has not yet been developed on the upstream side. There is a lot of potential there with the Horn River Basin, with the Montney Basin, but these are reserves that would require a new market before they're being developed. So these two things will go hand in hand. And on the liquefaction side, in the US, all of these projects are largely brownfield. The ones that have been approved so far, only one of them is a greenfield project, and that's on the West Coast. That still has a lot of questions for local permitting. But all the other ones are brownfield projects, which means significantly shorter lead times for construction and lower costs. For Canada, that is not the case. Virtually all of these projects will be greenfield. They would require not only the construction of the liquefaction plants, but they would also require construction of pipelines to bring the gas from the Horn River and Montney Plains into the coast areas, and also actually the development of the upstream sector. Now, on the demand side, Asian consumers really dominate this space, and this is how really LNG markets emerge. It's because consumers such as Japan and Korea that don't have indigenous supply needed to develop their natural gas-based power generation. And as you can tell, Asia consumes around 74% of total LNG in the world, and 36% goes to Japan alone. Very, very significant buyer. The second largest one is Korea, and you can see the next one is really China with 7%. Now, this landscape is changing just about as rapidly as the landscape for global liquefaction is changing. Could we move forward, please? First of all, Japan has clearly gone through a major transformation with having to shut down all of their nuclear generation as a result of the earthquake in 2011. With no nuclear capacity running at the moment, their needs for LNG are very high. That is putting cost pressures on the economy, and there's a lot of pressure to restart some of the plants. There are indications that Japan might do that, and that's likely to lower some of their demand. But in our view, it's not likely to drastically shift the current situation. Certainly not in 2014. Probably moderately would lower demand for 2015. But this remains a big question for the LNG markets because Japan has not yet decided which way they're going to go with nuclear generation. There's opinions on either side. Their recent energy policy directive that they came out with, I think, in February, looks at nuclear power as part of a stable and reliable supply mix, but certainly there are questions with regards to reestablishing the permitting for these nuclear plants, many of which are coming close to their 40-year timeline that they're permitted for so far. If we could flip to the next one. Another big change is the emergence of China as a large LNG buyer. Just until as recently as 2008, China barely had any LNG imports. And they've started adding regasification facilities at a very rapid pace. The Chinese market is constrained by the availability of supply. If they can get more gas, they absolutely will use it. They need to be changing their power generation, but they also need to be gasifying their cities and moving them away from using heating fuel for residential commercial consumption into natural gas. which is much cleaner and can be significantly cheaper. They're doing that not only on the LNG space, but also with pipelines. China has been very aggressive in contracting pipeline imports, and in all likelihood, they will need both sources of supply. The chart on the right-hand side gives you a perspective how big of a consumer China can become after they're done building their regas capacity that they're currently planning to have by 2020. Japan currently uses just under 12 billion cubic feet per day. After China is done building their facilities, they will come up to around 9 BCF per day. That'll put them basically as the second largest consumer of LNG in the world. If we could flip to the next page, please. Now, this is coming against the backdrop of a Europe that is increasingly reliant on imports as well. So far, European markets have not been the key driver of LNG demand. In fact, they have been redirecting their LNG contractual obligations and diverting the cargoes to Asian consumers. That's because their demand has been very, very soft with weak economic activity. But should that change, domestic production is not keeping up with the pace of demand. It hasn't been, even in this weak situation. So they are increasingly reliant on imports, and they're forecasted to continue to be so, at least over the next several decades. The chart you're looking at comes from the International Energy Agency and their forecasts for the European trajectory of supply and demand for natural gas through 2040. Could we flip to the next page, please? And then Latin America and the Middle East have been another emerging buyers in the LNG markets, and they're important because their demand is counter-seasonal. If you think about when their biggest needs are, it's during the Northern Hemisphere Northern Hemisphere summer. The key demand driver there tends to be Brazil. They use LNG as a way to balance their power generation mix in the years where their hydro is very poor. And that has happened in the past couple of years for them. So they have been a very aggressive buyer. They come into the spot market, and they really can drive the market in a time when the Northern Hemisphere is a bit of at a lull. Could we flip to the next page, please? So clearly, with so many different regions in the world participating in the global LNG space and more cargoes traveling and being redirected, one would think that there might be coming a time when we see kind of a convergence of global gas prices. But that couldn't be further from the truth of what we have seen happening so far. Perhaps the largest reason for that is the fact that the US has gone through its shale revolution. Being North America being an island on its own, not having facilities to exchange natural gas with other continents, unlike Europe, which does, this has remained an isolated phenomenon. So gas prices in the US, having decoupled from oil, have remained among the lowest in the world outside of the areas that have stranded gas. We certainly couldn't be competing with places like Qatar that have stranded gas in their markets where supply far exceeds what the country could use. But compared to any other traded market, certainly the US is the lowest by far. And our analysis suggests that this is likely to continue to be the case. Thank you so much. The chart you're looking at gives you a perspective for just how wide the disparity is. US is at the very bottom. Then you're looking at the blue line and the navy line. That is UK NBP and Russian gas delivered at the border of Germany. You can see the two have kind of, in fact, all of these price points have traded relatively closely in the past, up until 2010 when they really start to diverge widely. And this is in particular for Europe, it's important to look at how Russian gas deliveries into Germany compare with UK NBP, because that tends to be one question that the market looks at. Well, can European, if pipeline imports were to be priced at gas linkage as opposed to oil linkage, would that actually mean a significantly different price? And it seems like the market is telling us it would not. And that just has more to do with the cost of production and the fact that Europe still needs to be a net importer, and the cost of production there is not nearly as low as it is in the US. And so that to us suggests that the cost in Europe is likely to remain kind of in the current band where it is, and still somewhat linked, not exactly to parity with oil, but to the movements in the oil price, unlike in the US, where the two have completely decoupled, and we really don't see a reason for them to reconnect in the foreseeable future. And then finally, the Asian markets, which have gone into higher territory all on their own, you might think. That has been a result not so much of gas, but of oil prices. In Asia, natural gas is priced as a function of largely Japanese crude cocktail price, JCC. And that's just an average blend of what Japan uses in terms of oil imports. That is the case because it's the best proxy for an Asian hydrocarbon market in the oil and natural gas space, where they are interchangeable in the power generation sector. And actually, that's also the reason why in the US, oil and gas used to be linked, is because we had natural gas used to trade in a BTU parity range between residual fuel oil and distillate fuel oil. And if we needed to lower demand, then gas prices would jump and cross distillate fuel oil parity, turn off gas-fired peaker units, turn on distillate fuel oil peaker units. And the reverse was true. If natural gas needed to gain some demand, we would drop below residual fuel oil. Clearly, we have dropped way below residual fuel, and we don't need to be there. In fact, we're competing with coal. So it's that disconnect that's driving really the disconnect in global prices. And that's a very important point because it sets the stage for what global LNG markets are likely to look like in the context of Henry Hub, US LNG exports introducing a Henry Hub linkage into the global long-term contracts of LNG. Could we flip to the next page, please? Thank you. So as I mentioned, the traditional LNG long-term contracts are linked to JCC. And JCC really is kind of very, very closely related to Brent. And those are the three lines you're seeing on the first chart. You can clearly see that the escalation of long-term LNG contracts is virtually entirely due to the escalation of oil prices and not to some changes in the slopes of contracts. Those are changing, but the changes have been far smaller than the order of magnitude of changes in the oil prices themselves. Now, the second chart gives you a perspective of what a theoretical arbitrage between Asian LNG prices, say Japanese LNG prices, and US LNG exports would look like. It's theoretical because we don't have it, but had we applied the formula at which the US, Sabine Pass project in particular, has signed their offtake agreements, that is what the chart would look like. You can clearly see that the discrepancy really stood out wide starting in 2011 and has remained roughly in a $4 range ever since then. If you take current pricing, Japan currently imports LNG at around $16 per MMBTU. At $4.50, US LNG would land in Japan at around $12.50. So we're still maintaining that type of lower cost advantage. Could we flip to the next page, please? So with the US having approved a significant amount of capacity, virtually all of the Sabine Pass projects are the only ones that have announced their price terms for the offtake agreements. The other ones have not done that. They also have not reached final investment decisions because they're still waiting for their FERC permits, even if they are DOE permitted. So we're yet to see how those will be set, but all indications are that those facilities are likely to be tolling agreements. So the buyer will only be paying for the liquefaction fee, and they will be responsible for procuring their supply in the spot market. So effectively, it would be a Henry Hub-linked type of supply for them. And then the other piece that I'd like to note here is, if you're thinking about how much US LNG would cost, by the Sabine Pass formula, that's roughly 115% of Henry Hub. And this 15% is not really a premium to the supplier, to the producer. It's really what it costs to manage the basis risk of delivering the gas to the facility and all the other operational costs around it, like fuel charges, plus $3, which is the liquefaction fee. That is the take-or-pay. That is what the buyer is paying, is the $3 liquefaction fee. And that price is free on board at the terminal in the US, which means the buyer still needs to pay for transport, which tends to be $3.50 to $4 if you're looking at taking it into Asia. So that's roughly how the 12-something per MBTU delivered in Asia breaks down to, if you're looking at it from a Henry Hub basis. Could we flip to the next page, please? So finally, just to wrap this up and give context to Guam's needs for LNG. One of the things that would set Guam apart is the fact that the needs for LNG are likely to be fairly small. I used some number of megawatts just as an example to give you a sense for scale. In this case, I used 320 megawatts, which is probably too high. But that would require, assuming 7 heat rates and around-the-clock kind of baseload use, around 55 million cubic feet per day of natural gas. 55 MMCF per day compares to a small LNG tanker that generally carries about 3 billion cubic feet per day. If delivered ratably over the course of a month, that would mean about 100 MMCF per day of demand, right? So clearly it's less than 1 tanker per month and one small tanker. And what this means is that you would be looking for a solution that's tailored specifically to Guam's needs, to the scale of Guam needs. And I'm sure my colleague who will be speaking after me will be addressing some of that as well. And it also means that storage would likely be important for this because it costs a lot to charter the tanker and keep it there while it's regasifying. So with these couple of considerations to have in mind, I'd like to stop here and pass it on to Zick to introduce our next speaker. Thank you.
Well, our next speaker is going to talk to us a little bit about the potential LNG strategies for Guam. Doug Cotton. Doug and I have been working together pretty furiously here since September, if not August. Doug is the senior project manager with HDR. He has been responsible for the FERC permitting processes and preparations of federal and many federal EIS and a number of LNG import projects. So with that, Doug, we'll hand it over to you and tell us about strategies.
Well, thank you. Half a day, everybody. You know, I've always wondered whether the worst speaking slot at a conference is the one right before lunch or the one an hour after lunch when the afternoon drowsiness starts to set in, but we'll try to keep it interesting. Please pardon my scratchy throat. I'm also coming down with a cold here. Now, as Zig mentioned, I'm working with HDR, and HDR has been assisting the Guam Power Authority for the last few months, looking at alternative ways of bringing LNG into Guam. What I'm planning to present today is a snapshot of where we stand today in our analyses. I just want to make sure that everyone recognizes that it's a process that's going forward. As Ken mentioned earlier today, the next 6 to 9 months, GPA will be working with all the various stakeholders to try to figure out what is really the best approach for bringing LNG into Guam. Next slide, please. As has been mentioned multiple times today, GPA has determined that natural gas appears to be the lowest cost fuel for repowering the generation facilities here in Guam. The estimated demand is approximately 250,000 tons of LNG per year, which, as our previous speaker mentioned, is a small amount. This is even less than the numbers that she was using. Gas would be brought to Guam, we believe probably from the Asia market. While we just saw the presentation on the large new quantities of gas that are going to be available in the U.S. for those lower Henry Hub prices, we're not sure it's practical to rely on those here in Guam, both due to the distances, but also due to the fact that there is this thing out there called the Jones Act that requires that all shipments between states occur in U.S. flag vessels that are also U.S. owned and U.S. crewed. There aren't any LNG carriers out there that meet those requirements, nor is it likely that the U.S. shipbuilding industry is capable of building any large ships that would be able to bring a cargo of LNG from the Gulf Coast through the Panama Canal out to Guam, or even from the west coast of the U.S. As also mentioned earlier, the target date for the LNG being here to support the generation facility conversion is approximately the year 2020. The process going forward will be a long and arduous one, but we do anticipate initiating the formal permitting process either at the end of this year or early in next year. Next slide. Well, again, why LNG? Again, it is the cleanest fuel, lowest cost. And again, as our previous speaker mentioned, there are large new sources of supply coming on over the next few years, Australia, Papua New Guinea, the U.S., and Canada. So we believe that the availability of LNG will be good over the foreseeable future. And again, it is a very clean fuel and has the lowest emissions of greenhouse gases. So that's very important for Guam's environment and economy. Next slide. I think we should maybe just take a step back here and just understand, well, what is LNG? Well, LNG is it's natural gas in liquid form. If you take natural gas and you chill it down to minus 160 degrees C, it converts from a gas to a liquid. And in doing so, you get a 1/600th reduction in the volume. And that makes it economical to transport gas as LNG over long distances, either in ships or in railroad cars or even in trucks. LNG is a commodity that's only recently being exported, and lots of places don't have experience working with LNG, and folks kind of not really sure what LNG is. Well, LNG is a lot like propane, and Guam has been using propane for years. It's being used in homes, it's being used in hotels and restaurants for cooking and for heating hot water. Propane tanks are a fact of life, and you see them all throughout the landscape. Propane is brought into Guam about every 2 weeks in a ship, comes into Apra Harbor and docks at Pier F1 and unloads a load of propane. So Guam has a lot of experience with propane, which is very similar to LNG. I do want to point out there is a important difference between propane and LNG, or natural gas, in that propane is 1.5 times heavier than air, whereas natural gas is lighter than air. So if you have a spill of propane, it pools, whereas if you have a spill of natural gas, it'll evaporate up into the air. Well, how do we get LNG to Guam? Well, in countries that have large supplies of gas, they are now taking the gas and sending it to liquefaction plants, who then chill the gas, make the liquid, put it in a storage tank, and then fill LNG ships with the LNG. Now these ships, called LNG carriers, then bring it to an import terminal where the process is reversed and the cargo is offloaded into a tank. The LNG is then vaporized and then put in the pipeline and goes off to serve the customers. Next slide. Before I move on, I did want to point out that the work that we're doing with the GPA involves identifying locations for that LNG import terminal here to serve Guam. We've taken the previous studies that have been conducted for GPA and others here in Guam and identified some sites where we could locate an LNG import terminal. And as we're identifying these options, we're looking at those from 4 standpoints. One is overall feasibility. Has this been done elsewhere? Is it within the state of current technology? We're also looking at how that might impact the Apra Harbor operations, since that's where we're looking for the facilities. Would bringing in LNG carriers or establishing a terminal, would that interfere with current uses? Would it cause some problems with existing facilities that are in the harbor, or would other facilities interfere with the use of the LNG terminal? Now, of course, we're looking at compliance with safety codes and standards. Public safety is the utmost of importance. And we're also evaluating the potential impact on the environment. Apra Harbor has aquatic and terrestrial species. There are coral reef resources or protected habitats, and there are cultural resources, so we need to be very, very cognizant of those as well as we move forward. As we've looked at the impact of bringing LNG into Apra Harbor, first we started with how would we get the LNG and what kind of LNG carriers might be visiting the harbor? Since the volume that's required here is so small, we believe that we'd probably be looking at small LNG carriers that would be bringing in the LNG, not the larger ones that, say, would bring a cargo from the Gulf of Mexico to Japan. Now, those ships would likely be carry 225,000 cubic meters of LNG and be almost 1,200 feet long. we believe that a good option for Guam might be a smaller LNG carrier, such as on the left here, which would carry 23,000, maybe 25,000 cubic meters of LNG, and the ship itself would only be about 500 feet long. There's another option that we're also looking at is using larger ships to bring in larger amounts. And again, we're still looking at smaller size ships in the global scale of LNG ships. So we're looking at a ship that might carry 122,000 cubic meters and be about 900 feet long. Now, these are ships that are out there in the current marketplace delivering LNG, so we're not. We're using existing ships as kind of our model. Next slide. The size of the vessel and how much it carries would have a direct influence on how many visits the LNG carrier would require over the course of a year to deliver the volumes that are needed. A 23,000 cubic meter ship would have to visit the port and deliver a cargo about every 2 weeks. If we were able to use a larger ship, such as the 122,000 cubic meter ship, you wouldn't need to every 2 months would be the frequency of delivery. So there's a big difference there in terms of how frequently a ship would have to come through the harbor and deliver its load based on the size of the ship. But of course, the facility would also have to be able to accommodate that load, so you'd have a much larger facility if you had a larger ships visiting. At this point, I'd just like to also mention the kind of the way it would work. An LNG carrier, wherever it's coming from, would approach Apra Harbor, and the Coast Guard would go out and meet it out at the pilot station outside the harbor. And they'd likely do an inspection of the ship, and then the LNG carrier would come into the harbor, assisted by probably 2 tugs, and there'd be a guard vessel, and it would make its way through the harbor to wherever the berth would be. As it approached the berth, the tugs would turn the ship and then push it into the berth. That whole process would probably take maybe a half hour to an hour, depending on where the location of the LNG terminal is. And during that time, all other vessel traffic in the harbor would have to stop. So there would be a period of disruption, half hour or so, while the LNG carrier is being put in the berth. Once it's at the berth, all normal vessel movements can restart. And the only thing you would see is there'd be a guard vessel stationed at the LNG carrier. They would just make sure that vessels didn't come within a certain distance of the LNG carrier while it's offloading its cargo. All of that would be done under the direction of the captain of the port of the U.S. Coast Guard. Again, that's pretty much what happens now with the propane deliveries. When the propane ship comes in, all of the traffic stops. When the propane carrier gets over to its pier, then the other traffic can start up again. As far as the terminal goes, we've identified that there are 2 options that seem to work for Apra Harbor. One is a land-based facility, shown on the left. Here, the LNG carrier would come in, tie up to the pier, offload its cargo into a storage tank, and then the carrier would then go off on its way. The LNG would then be pumped out of the tank at a rate and then vaporized, put into the pipeline system, and that gas would then go off to feed the GPA's power plants. The second option is using a ship as the LNG terminal. The ship is called a floating storage regasification unit. The floating storage regasification unit, or FSRU for short, would be moored at a jetty, and other LNG carriers would come in, tie up alongside the FSRU, transfer the cargo into the FSRU, and then they'd be on their way. The FSRU includes the vaporization equipment right on the ship, and so the gas would be vaporized on the FSRU and then pumped onto shore into the pipeline system where it would go serve the end users. One of the benefits of a FSRU is that the FSRU can be built as a package in a shipyard and just sailed to its location and tied up at the berth. So it offers an opportunity to get a complete package developed in a shipyard and then delivered in place probably a year or so, faster than you could build a land-based facility. So the FSRU has a number of advantages, including the fact that you're putting it on the water, and places like Guam, most islands are limited in the amount of land they have. So oftentimes land is very limited, and doing it on a ship makes a lot of sense. So those are the two facility operations that we're looking at now that we believe are feasible for Guam. Next slide. When we started off with this process, we kind of took a step back and tried to look at all the possible locations we could locate the LNG terminal in. And if you look at Guam kind of from the high level, the first thing that strikes you is there are a lot of parts of the coastline that are protected marine protected areas that you definitely wouldn't want to put a LNG terminal at. There are some other bays that might be possibilities too, but they're very shallow and reef protected, full of coral, and they're not such a good idea to put an LNG terminal there either. So really, it does come down to Apra Harbor. And luckily, Apra Harbor is a large harbor. It's well protected, and there appears to be places where we can put an LNG terminal. And we can start looking at those now. Next slide, please. We've identified 8 different site options and have evaluated those. 6 of those are land-based facility options, 2 are FSRUs, and 1 doesn't include an LNG terminal at all, but it rely on bringing in LNG in those 12,000-gallon ISO containers that were mentioned earlier. The ISO containers are essentially thermos bottles. They're 40 feet long. They're equivalent to a shipping container. It can be handled by normal shipping container handling equipment, both the ships and the cranes, as well as the personnel on shore. It was also mentioned earlier this morning that the Hawaii Electric Company has recently issued a request for proposals to gas suppliers to supply almost their entire demand of LNG with ISO containers. HECO's demand for gas is about 3 times Guam's demand for gas. So it'll be interesting to see how that proposal plays out over the upcoming months. But that is one of the options that we're also studying. As we're looking at these alternative LNG terminal locations, we're looking at key siting factors such as deepwater access, public safety, of course. The most important one is public safety. The availability of land, the proximity to the power plants, just the overall technical feasibility. Can we actually build and operate a facility there? Impact on environmental resources, and not unimportantly, the cost. Our evaluation is continuing, but we have identified, as I mentioned earlier, we have 2 options that we think are feasible that should be looked at further, and there'll be some decisions that need to be made about which one makes more sense, but we're really pleased that we've found a couple of really good options, we think, for Guam. Next slide. Now, this slide shows the range of sites that we've evaluated for establishing an LNG terminal in Apra Harbor. Our options are kind of a mix and match of LNG terminal berths with LNG storage and regasification sites. I won't get into all of them here, but we do have a number of options, and why don't we move on to the next slide? We can start talking about one of the options that rises right to the top of the list is in terms of feasibility. And this is the land-based option. This would be located out off of Route 18 at the site of the current yacht club. How this would work is the LNG carrier would come into Apra Harbor, or would approach this area, would be turned and then backed into the berth. It would unload its cargo into a cryogenic pipeline, which would transfer the LNG across Route 18, probably under the road, into the storage facility, which would be located on the other side of the road. Gas would then be vaporized and then sent out by a buried natural gas pipeline all the way over to the Cavris power plant. Next slide. This is a bit of a blow-up of this site. What you can see on this slide, not only is you see the facility layout, but you can also see those circles, which are the estimated vapor exclusion zones. By code, these zones need to be established for LNG handling facilities based on certain set rates of accidents and releases of natural gas. And these zones will be established both around the operating facility and then around the LNG carrier as it's offloading its cargo. And other than the building at the yacht club, there are no occupied structures within these zones. The government of Guam owns the land, and there doesn't appear to be any other reasons that this doesn't meet all the technical codes and health and safety codes for establishing an LNG terminal. So we're pretty high on this one as a potential option for Guam. Go to the next slide, please. The second option that we're looking at is establishment of an FSRU out at Hotel Wharf. Again, the FSRU would be moored against Hotel Wharf. LNG carrier would come in, unload its cargo into the FSRU, and then the FSRU would be there permanently, vaporizing the gas and pumping it into a buried natural gas pipeline that would run down Route 11 down to the Cabras power plant and deliver its gas to the GPA system at that point. If we move to the next slide. This is a blow-up of that site and how that would look. Again, we have the FSRU, the pier that it would be moored to, and then the land-based facilities that would accompany the LNG carrier there, well, the FSRU, and of course the LNG carrier when it's at its berth discharging its cargo. One important feature to point out that both this site has and the previous land-based site have is the ability to take the LNG out of the storage tank and put it into an ISO container or a truck, and then use that LNG to serve other demand for LNG, such as maybe one of the remote GPA power plants, or converting the bus system over to LNG, or natural gas using LNG, or taking the LNG and then using it to fuel other marine vessels. There are new EPA requirements on marine vessels. They're very similar to the EPA requirements on the power generation fleet. That's going to require them to be using low sulfur fuels as well. And again, just like with the power plants, vessel operators have the same choice of putting stack controls on, converting to ultra-low sulfur diesel, or burning LNG. And so we believe LNG is going to be a fuel of the future for the marine industry as well. So having the ability to take LNG out of the storage tank, whether it's the land-based facility or the FSRU, is a very big plus for a facility here in Guam. Next slide. Now, we are aware, having had discussions with the Port Authority, that there are plans in the works for looking at establishing a cruise terminal at Hotel Wharf. So we have looked at other alternatives for an FSRU out in that area. This figure shows the establishment of an FSRU kind of halfway between Hotel Wharf and Gulf Wharf. This particular one would not be attached to the shore, and it would only be able to provide gas and not LNG off of the ship onto a land facility where you could fill ISO containers or trucks. There are some other issues with this one too, but it's something we're also continuing to look at as maybe another option for establishing an FSRU to provide the gas that GPA needs. Next slide. Of course, another important element of our evaluation is look at the environmental impacts, the potential environmental impacts of these facilities. So here's just one of the analyses that we're conducting, looking at the impact of establishing each of these options or locations as they relate to the very important coral resources in Upper Harbor. There are hawksbill and green turtles that both forage and nest in Upper Harbor. There are a number of other habitats in Upper Harbor, and of course you have the marine preserves, such as the Sassa Bay Marine Preserve, or the Pehlivanova Marine Preserve. So those are all things that we're looking at as well, as to how might these facilities impact the environment. Very important part of the analysis. I can point out to date that we haven't found any major environmental impacts from any of these locations, and particularly not the locations that we think are the two most likely ones, the FSRU at Hotel Wharf or the land-based facility there off of Route 18. Next slide. Well, our findings to date. Again, we believe that LNG is the lowest cost option for Guam to generate its energy that it's going to need. The LNG is readily available in the world market. We just heard that presentation earlier. There's plenty of LNG out there, and looks like there will be in the foreseeable future. LNG can safely be brought into Upper Harbor. We can safely establish LNG import terminals that will operate within the safety codes that are out there, and can then be distributed to the GPA's power plants. We've got two options we think that are pretty good, and the process of trying to identify which is the best option for Guam is going to involve ongoing consultations with stakeholders such as you, government Guam agencies, and others, so that we can come up with the option that works best for Guam. Last slide. And finally, the steps going forward, these were also mentioned earlier. The GPA is in the process of finalizing its resource implementation plan that it will file with the PUC. Following PUC's review and assent to that plan, the implementation of the LNG program will start. One of the key agencies that we'll have to work with for development of an LNG terminal here will be the Federal Energy Regulatory Commission, the FERC. We are hoping to start that process end of this year or early next year, and get the process formally underway with the FERC. And once the FERC and other approvals have been granted, then implementation of the plan and actually construction of the facilities, again, with a target date of getting everything up and running by 2020. Next slide. Thank you very much, and we'll be taking questions later, I guess. Thank you.
John is the Strategic Planning and Operations Research Division, stands for SPORD. He's the manager. He heads up an eclectic team of engineers from the electrical, energy efficiency, IT, chemical, and mechanical disciplines. So with that, John, we'll pass it to you, sir.
Well, thank you, Zach. Thank you for the nice intro. This presentation is an amalgamation of a lot of work by those people that are listed. My staff, John Beneventi, there were just too many people to put on there, right? So this project is really the combination of work of everybody in GPA, basically. Next. We come to an evolution of a vision, right? Since 2008, Federecki talked about the 2008 IRP. We thought, well, LNG, renewables, we need to take a look out on the horizon for US EPA regulations that are on the drawing board, right? We started off and put in some renewable energy as a result of that, and really started to drill down into the details of environmental compliance, LNG, and all the other factors that come into play to make a viable energy solution for the future. Okay, we did an environmental strategic plan to clear the way for how we were going to need to comply. The RICEMAC, the reciprocal internal combustion engine, ended up being that regulation ended up being big driver for the IRP that we submitted in 2012. Right? So all of these factors coming in together, the nascent industry, the PV industry, we have 1.3 megawatts of renewable energy, but Hawaii was at that same point at one time, and then it went exponential. Okay? So in those 6 years, we've taken a lot of analytical brain power, a lot of consulting time, a lot of conversations that we've had to evolve this idea of a vision. Okay? Next. And it really centered around customers. Click. Can somebody click it? Okay? And we did market research with customers. And they essentially were looking at, in terms of what meant satisfaction for them, was having affordability, right? Was having fewer and fewer outages, better power quality. And we thought, okay, let's take a look at cost reduction strategies. What do we have under our control that we can manipulate and plan for and build so that we can meet these targets of reducing costs so that people don't have to fork over a substantial part of their hard-earned dollars for energy. Energy is getting really expensive. Click. Okay, click again. All right. Can somebody click? All right. And we took a look at reserve and reliability, for instance. If we can make a system, a generation grid system, where we needed less reserve and we could achieve as good or better reliabilities, then that was something that we needed to look for. Next. Okay. Took a look at grid stability. Right? We have a whole bunch of outages that occur because of under-frequency relay tripping. Okay? When generators trip, we trip load. And we trip a substantial amount of customers throughout the year. And that is a problem. When we did our market research and our residential customer satisfaction survey, right? There were a certain bunch of customers that had 20 outages. About 20% of our customers, 28% of our customers had residential customers had over 20 outages, and they're the ones that really rated us low in terms of customer satisfaction. Click. And power quality. So putting the best minds that we had at our disposal, John Benavente, Ken Flores, my group, Melinda's group, the engineers, right? The lawyer and the finance people, right? We evolved this vision that we're about ready to be launching this big IRP effort. Next. Legacy generation. We took the IRP, when we submitted it in 2012, it called for the retirement of Cabas 1 and 2 and the retirement of Tengisan 1 and 2. But, the PUC asked us to dig deeper and see if we could find some additional value in retiring legacy generation. And under the leadership of John Benavente and others, we took a look at being more aggressive in terms of what else could we retire. And at some point, at the very bottom of that list is Cabas 3 and 4. Right? By the time 2026 rolls around, those units will be about 30 years old. Okay, so it is on a list of potential retirees. The rest are pretty much firm. We will have retired about 334 out of 552 megawatts of capacity existing on the island. And LNG conversion, it would remain that MEC 8 and 9 the IPP unit would be the only one that would be converted over to gas. We'd still remain on diesel for some of the smaller combustion turbines and our small PACMAC diesels, PACMAC and Wärtsilä diesels. Next. Then the new generation. The new generation, we assumed in our IRP about a 40% efficiency, but their units, and that was being conservative. We didn't want to overwhelm the case for LNG. We wanted to be really conservative. So we took a look at deeper into it, and at a 50% minimum efficiency for gas-fired units, now came the opportunity to say, hey, if we retire these older, less efficient units, even if gas were not at Henry Hub prices, right, we're more in line with RFO prices, we still have a really good, strong business case for bringing in LNG. 93 to 95 minimum availability. The better the availability and reliability that your plants, your generation mix has, right, the more reliable the entire system is, and the less reserve that you have to carry. At one point, I mean, currently we have over 100% reserves in terms of installed capacity. We have a peak of about anywhere from, on any given year, in the 250s, 260s, or 270s. Okay, we have 542 megawatts of installed capacity. After the IRP, in 2012, we retired 10 megawatts of Dedido diesel and 16 megawatt combustion turbine at Marlborough that Commissioner Pete over there had us take off his hands back in the old days. We're taking a look at, we're considering about 120 megawatts to 240 megawatts of new generation capacity depending on load growth. We want those units to be fast reacting. We want them to be outsourced to IPPs, our IPP model. We're not going to own another. We are not going to own outright a generation asset. Right? The IPP models and the PMC models have been our saving grace. Back before 2003, our generation availability on our base loads was 67%. Right? It's much closer to in the high 80s to low 90s currently because of IPPs and performance management contracts. T&D impact. We're going to hook up this new generation to the 115 kV, depending on where we put it. And the most likely candidate, the lead candidate right now is to put it up at the Marlborough CT area. So we'd have to extend our transmission system, our 115 kV system, up to that location. And we need to build gas and ultra-low sulfur diesel supply pipelines to this new power plant. Next. System reserve margin target. Currently, we have over 100% of reserve. To meet our criteria of 1 day and 4.5, you need about 60% reserve. With this new generation, we would be looking at anywhere from 30% to 45%, most likely closer to 30%. 30% is more like the two largest units. So we'll start, our reliability criteria is the greater of 1 day and 4.5. Loss of load expectation, the amount of reserve to meet that, or the two largest units. And at some point they cost. That would be around the 30-some%. There's a tremendous reduction in generation FTEs. These plants that we have now, there's probably over 100 employees at these power plants. As you retire them, right? I've just been to a field trip up at Antioch, California, close to San Francisco. We visited Simon Sanchez and I and others visited a combined cycle combustion turbine burning gas that PG&E owns and operates. It's a about a 250 megawatt plus for each simple cycle combustion turbine, right? It's got two of those power plants plus a heat recovery, a HRSG. So in essence, it's over 500 megawatts worth of power at this one site. Okay. The footprint of this power plant, it's kind of roomy. They said about 10 acres, and they think that one of the advice of the person giving the tour is that he thought that we would need about 5 or 6 acres to put in the units that we were taking a look at, the LM6000s. But all in all, this means that over the next 7 years, we're going to have to take a good look at organizational redesigning and right-sizing and making sure that all the employees that are affected, right, that they either have some place to go, early retirements, retraining, outplacement. So, you know, we're part of the community and we're sensitive to that. But at the same time, there's a lot to be gained from 100 or so employees down to as much as that, you know, that 500 megawatt plant, they take 23 people. There's 23 full-time staff, and a lot of the big work is done by contracts that they come in periodically on a scheduled basis. So change management. So our project is not only going to change the way we generate electricity, it is going to streamline Guam Power Authority. We will be a smaller, more agile, more customer-focused utility after all of these changes. Next. LNG infrastructure, land-based. Doug Cotton was talking about it, right? I'll just flip through these slides real quickly. Is it going to be an RFSU? Is it going to be a phased FSRU and at some time land-based? Right? Are we going to have more than one site for LNG storage, or are we going to have LNG and then diesel as the backup? And if there should be anything with the problem with one of the LNG storage sites, we'll be burning diesel. So, you know, all of those are the questions that we need to answer. Next. You've seen this slide. This is on Doug's. Next. These are exclusion zones. Keep on. So those are just some of the examples, and he really covered it well. Next. The financing versus business model. How much is this going to cost? How are we going to finance it? Well, we really need to put some heavy decision making on what type of business model we're going to adopt. Are we going to bundle everything into one super contract for supply or LNG infrastructure, generation, unit conversions, and pipelines, right? Or are we going to structure it so that there's different contracts? Okay, there are plus and minuses for each one of these things. Are we going to have are we going to own it? If we own it, then we're going to need to do all of the design work and all of the funding and financing. So that's a bigger job. If we're going to outsource it to an IPP, like an IPP for LNG infrastructure, then that would more so entail a bunch of performance criteria and contractual clauses that protect our interests and ensure that we have what we need to run our system. It's about $800 million in capital requirements. Horeki said it was about 750. That's in the IRP, and that's true. But we also added the batteries. Okay, so that's with the addition of the batteries. So renewables, new generation, LNG infrastructure, and batteries. Next. Energy storage study, that's near completion. You heard that from Dave. Dave's actually got a lot more work to do because this energy storage study has some other ramifications. It has ramifications with automatic generation control, right? with what inverters and equipment that we need to specify for rooftop solar systems, for distribution modeling. But the energy storage study, the study objectives substantially reduce outages, reduce costs, and promote future renewable energy integration. The preliminary cost results are spinning reserve, added spinning reserve. We can minimize the spinning reserve and use batteries, and it makes for a more cost-effective, financially feasible alternative. Next. Energy storage benefits: improves system reliability, improves power quality, reduces fuel use costs, and improves customer satisfaction. One of the questions that, and we use J. Merrill as our market research firm, we ask customers, are you willing to pay less if reliability of outages increased? And the answer was no. So affordability is their #1 issue, right? But the level, the bar of satisfaction is they like this reliable power, right? People used to go and say, oh, we're a lot better than we were because we don't have any of the major load shedding. Now the bar has raised. They're not worried about all of that massive load shedding. They're worried about their quality of life and having less outages. Next. Improve system reliability. Dave brought about the under-frequency load shedding. Okay? We have quite a number of those happening throughout the year. I think 28 first stage under-frequency outages in 2013, for instance. Okay? And energy storage is going to help us get a substantial part of those outages out of the way. Next. Improve system reliability. So the outage duration, the amount of outages for each customer, right? An energy storage system of 40 megawatts will reduce that by 77%. Okay? We will be a much more reliable system. Next. It improves power quality. That's a simulation with a wind and solar power plant, right? The intermittency that's in blue. So you see the system frequency jump all around the place depending upon the output of the solar and the wind, right? With the energy storage systems, that will be very much smoothed out. Next. Reduces fuel use costs. By reducing the spinning reserve that we require on the system, that enables us to put together and operationally have a dispatch that saves us more money, $18 million a year at the least. Next, with an increase in the battery capacity, 15 minutes to plus 15 minutes to several hours, we might be able to do some load leveling and shift the peaks and have one dispatch throughout the entire course of the day. And that may save us money. Next. Quantum, the renewable energy project. We did a system impact study, and the system impact study was with the acknowledgement that we weren't going to have those proponents pay for already existing issues that we have with our power grid. That's not fair. Okay, but the result was there wouldn't be a major impact in terms of a need for major mitigation. But when we get the batteries in, that helps resolve a lot of other issues that may come about with those systems and with further renewable energy penetration. Next. GPA's current challenge. We're going to have a lot of renewable energy. Okay, it's not all PV. could be wind. There are quite a number of wind resources here on island. It could be biomass, right? Which would be which has the virtue of not being an intermittent power source. That could be firm energy. So we need to embrace it. As a utility, we need to embrace it. We need to prepare for it. We need to reach out and work with as many elements of the community so that we can get ahead of the curve and avoid the problems that we're currently seeing in Hawaii. Okay? And I was, the week before last, I was at a distributed generation conference in San Francisco. And at that conference were a lot of people where renewable energy is as much as a religion as it is a feasible thing to do. And at the end of that conference, they acknowledged that we need a grid in order to increase the penetration of renewables and in order to maintain the quality of power and the quality of life that we enjoy from a stable power supply. Okay, next. And we came upon a question, and it was a legislative question. They said, why don't we cut the number of, the amount of batteries, because battery prices are decreasing. Yeah, they are decreasing. Solar is decreasing. There's a lot of these new technologies are just getting better and better, right? But one of the issues with us is that the energy storage system needs to be of a sufficient size or it's not going to be doing anything. 25 megawatts of battery actually on our system loses money. It's not a good investment, but 40 megawatts actually is a huge investment for just an incremental cost of about $15, $20 million. Okay. Next. The benefit cost analysis, that shows about 196 million. Next. And the energy storage is in two-phase implementation. Okay, the first phase, let's put in this 40 megawatts and get the most bang for our buck. Take a look how energy storage prices are dropping and the technology advances. And at that point where we're able to gauge the performance of these systems and plan in new innovations, then we will add those different technologies. That's under phase 2. And the future funding source, we would like that to be 2014 bonds at the discretion of the legislature. Next. Phase 2, I already repeated that. Next. Renewable energy. We've signed 2 power purchase agreements. I know some people have said that, you know, we'll have the first megawatt and GPA hasn't done anything. But by the end of the year, we will be the largest producer of renewable energy on Guam, 25 megawatts worth. We have a utility energy service contracts with the federal government. The Army Corps of Engineers awarded us a utility energy service contract, which allows the federal government under the FAR, the Federal Acquisition Regulations, to contract with a local utility to put up for projects for energy efficiency, renewable energy, and water conservation. The water conservation is if you reduce your water use, you're actually reducing electric use. So we have a UESC with the Army Corps of Engineers, and we've submitted a preliminary audit up for the Army Reserve Center on April 2nd. It's their April 1st. We submitted it to their Huntsville, Alabama office, and we potentially may have one with the Navy. Okay, and Desiree went in depth on that. It makes sense for a small island like ours to reach out with customers and to plan this together and make sure that a confluence of factors works in our benefit to create a multitude of wins. A win for our customers, a win for us, win for society. The GPA solar PV program, we have a rooftop and ground-based PV program. We're going to be announcing that fairly soon, in the next couple of months. That's about a 10 megawatt. We've gotten a lot of feedback from that conference that we went to, and have an additional arsenal of partners to help us solidify those RFPs, those procurement specifications. And then phase 2, which is about 30 to 45 megawatts of renewable energy of any stripe. Next. Demand side resources. Someone mentioned that the least cost power is the one that I don't need to buy or generate. So by planning the energy efficiency into everything, right, we reduce future demand, future need for new power plants, and reduce future costs. Taking a look at load control. Under the smart grid, right, we've managed to work with the Guam Waterworks Authority, and they will be using their SCADA system. Communications will be riding on the GPA's AMI, Advanced Meter Infrastructure Radio and Communication System. And as part of that, they will have control over the backup generation on every single water well and facility that they have. So in the event that we need to load shed somebody because of an insufficiency of generation, that we can avail ourselves of the 15 megawatts that Waterworks carries for us on our load. Okay. Time of use rates. That's something that we have the ability to do, and that is for another conversation that we need to have among ourselves. Each of the meters that we have has the ability to execute a time of use rate. Next. Energy efficiency. We have executed $2.5 million energy efficient streetlights program. You go down Marine Drive, you can see the LED lights. You go to Tuman, you see the induction lighting, right? That is a tremendous 50% reduction in energy use for lighting, okay? So that could be a major savings, and we have a program for a larger project wherein we'll be replacing 14,000 streetlights. We've done energy efficient retrofits for GovGuam, 8.4 million the first phase, and the second phase about 3.4. With our partners, our dear partners at the Guam Energy Office. I think Tina Muffness is back there. You know, all of these things wouldn't have been possible without the Guam Energy Office and the cooperation of the Governor's Office and ComEdA. We also had a solar water heater rebate program, and that was about 60 people got a solar water heater, primarily from the GRIA folks. And there was an $11.9 million Guam International Airport that we were a facilitator project for, which is going to save them quite a bit of money, thousands of dollars a day. Next. Smart grid. Okay, our ARG-funded smart grid program is base infrastructure. We are going to build upon this infrastructure, right? For a lot of the projects that we're going to be doing with renewable energy, we're going to have data acquisition systems so that we can get information that can help us make split-second, real-time operational decisions on what our loads and our generation, even our distributed generation, and is doing out there. We're taking information to make better operational decisions and better information to make better strategic ones. For instance, right now we have the capability of, on any given day, knowing how much money we're we will be collecting, right? That's not a, we would have to wait until the next meter reading every month before we get that kind of information. So that's a new information to help manage cash flow. So there's a lot of information that we didn't have, we can use and find new uses to make sure that we get more efficient. Best-in-class businesses run on real information, and that's an important thing. And that's what Smart Grid has given us. And we will build on this infrastructure. Next. Energy strategy, a summary. And you can see all of these projects that we have been involved in, they're actually part of an overall vision. They look like separate projects, but in the end, when you take a look at them under the context of future energy supply, they all apply. Okay, renewable energy, energy efficiency, energy storage, new generation, retired generation, everything, LNG. Next. Okay, and they have major impacts on improving reliability, on improving resource for loads, environmental compliance, fuel diversification, and energy efficiency. Next slide. Yeah, I think you've seen it in other presentations throughout the day. I hope this kind of brings it into the context that this is really one solution with many, many different moving parts. And it's taken us 6 years to get our heads around it and to look at it and scrutinize it and prod each other and have arguments to make it a better deal for our customers. Okay, thank you very much.
Thank you, John. Okay.
Okay, so I've learned that it's technically feasible. If we do this wisely, this will all work out great. So far, so good. My question really has to do perhaps with Biliana and Doug to some degree. So we know we can buy it. We know we'll be able to buy it. It may come from a variety of locales. Seems like Asia Pacific may be the first nominee because of its proximity. Same reason we buy our heavy oil from Singapore and not from New Orleans. The Jones Act makes it complicated if you buy it from U.S. to Guam. There sure seems to be, as much as I love my country, there seems to be a lot of other places we can shop for LNG. One of the things, I think the PUC, I think we're all wrestling with this. So how might we contract with a vendor? Right now, we've bought oil over the many years. Petrobras, Shell, who else can? Who? Oh, Vitol. You know, we've played with some major players. We presume we'll be playing with major players in the LNG market. But we sign a 5-year contract with them. It's market-driven. We just go up and down with price. We're pretty much just bidding on the shipping and the insurance, right? And the fact that they can do it reliably. I think Hyundai now is our new supplier. So, but with LNG, it's a little more complicated. How many vessels? We get one vessel every 35 days. We can store it. We know how to do heavy oil. LNG, the tanker has to fit the port. Maybe it's 2 weeks, maybe it's 2 months. We have to be able to store it safely. And the pricing, I guess, is changing globally, if I learned correctly, Biliana, between Henry Hub, the Japan cocktail, and with all this emerging commodity availability and emerging demand, pricing is going through changes as well. But maybe a big picture perspective. How might we think about, we're not going to need it till, what, Ken, 2020, 2021, something like that? We're not going to need it till then, but how do we think about contracting it? And what are you seeing out there? Are people signing, here's a 30-year contract, I guarantee you, here's my piece of LNG, and I'll reserve it for you, Guam, and you've got it forever? Are there folks that just accumulate supply and say, I'll broker it, I'll grab a portfolio, I may be getting it from all over the place, but for Guam, I'm going to grab it. Heck, Guam may not even know where the portfolio person grabs it. They just grab it, make sure the ship arrives, and we write them a check. how should we, can you teach us a little bit or give us some big picture perspective on how we might contract for it?
You're right. The market is definitely changing, and the U.S. volumes will be the first ones which would introduce a new long-term contract linked to a gas hub. In the spot market, there is already a lot of deals that are getting done at gas pricing, including at U.S. gas prices. And the most popular form in which that's happening is where countries like Argentina or Mexico, for example, they procure their supply by asking people to submit bids to deliver to them on a seasonal or an annual basis. So that's one way of going about it. You can actually run like a tender process for the supply in smaller chunks for smaller time frames. That doesn't, sorry? Well, Argentina does it on an annual basis. So every year they come in and they say, this year we're going to buy this many cargoes. We are looking for everyone's bids, and then they determine who they're going to work with. Similarly, Mexico does it in a comparable way. So that's one way of going about it, but that's not a long-term and not a very certain, right? That leaves you exposed to what the spot prices are. And in these cases, even though the countries are requesting a Henry Hub linkage to their pricing, effectively what happens is that the price they end up paying is linked to Henry Hub, but at the time when the bidding is happening, it's a fixed portion of the price ends up making up for the difference between oil-linked pricing and Henry Hub-linked pricing. It's not the same as saying they get it at a U.S. delivered price. There's a big difference between the two. So you can still have Henry Hub exposure in terms of the fluctuations of your index, of your indexation, but it's not the same as getting U.S. priced LNG delivered into a certain area. Was there another part of the question that I didn't address? In general terms, the way normally someone would do this, and I think this is where it's a little bit different for Guam because of the smaller size, but normally you're absolutely right. If, say, you are Osaka Gas, you would sign a long-term agreement with, for example, I think Cameron is the one they have it with, where Cameron specifically dedicates to them the liquefaction capacity. And in the case of a U.S. project, that's just the liquefaction capacity. If you're contracting supply from Australia, then the upstream portion is dedicated to you as well. So basically, the liquefaction projects, and actually this is more a function of the way that the industry needs to have long-term supply agreements to underwrite in order to be able to finance the liquefaction projects, because they're massively capital intensive. To give you a sense, well, the Australian projects are in the $50 billions of dollars, some of them. They're integrated. That starts from just getting the gas out of the ground, but also having different storage facilities around it, carbon sequestration, all sorts of different pieces to it. So you can't really think of it and compare it to a U.S. facility. But even for the U.S. facility, something brownfield, something that's already an existing regas terminal like Sabine Pass, the first 2 trains were contracted to the EPC firm alone for $4 billion, and the second 2 trains for $4 billion as well, right? So even in the U.S., that's almost $10 billion for just the EPC portion of the construction cost. They're very capital intensive. So you have to have long-term contracts, and that is why LNG is so expensive in general. That's why there's such a big disconnect between what you would be paying in the U.S. in the spot market versus what a U.S. LNG would be priced at.
And when you say long-term, what are you thinking that might be?
Generally, in order to finance the liquefaction plants, you would need a 20-year term contract. So that's the requirement that comes from the liquefaction facilities, not from the buyers. So on the buyer's side,
right, we're a little guy though. Would that work for us? I mean, is anyone going to care about our little amount of demand for their plant? Their big.
For their plant. Well, that's, yeah, because your volumes are so much smaller, they would not be sufficient to help a whole plant, but they, on the margin, could help someone who already has a contract. And that's where I think your other part of the question of the portfolio players that aggregate supply. So someone like BG, for example, they own production across different parts of the world, and then they have delivery obligations as well. So they're what's called portfolio player. They can reshuffle things around, and Shell would be a similar one. There's several of the big multinational players that would have that ability. So for small volumes like Guam, you could go with a tender process, or you could partner with someone who's a portfolio player who can manage it on their end and just be delivering to you what you're requiring.
And now that you've been here for 5 hours and heard us, if you were to make a call today, do you think we're going to be working more with a portfolio group rather than convincing some person building a really large plant that our volume is going to help them amortize that baby? I mean, just what's your professional instinct tell you right now? We're not holding you know, we didn't pay for you to come out here, so it's okay. You can guess. But just because that's what we're wrestling with. The PUC wants to know how are you going to finance this, and that all assumes where we're going to get it, and that assumes how we're going to contract for it. And that's what we're trying to sort it out. Are we going to be more of a portfolio player, you think, in reality, or do you think we might be able to successfully partner up? And will it be cheaper for the community to do the long term, or kind of wait and see how the marketplace matures? Because that was sort of my takeaway from November when I first heard you speak. That Guam's in a kind of a, be the second mouse. People are trying to figure all this stuff out now and stumbling around and getting clipped by the mousetrap. And that for our little market, no one's saying we won't be able to get it. The trick is what's the best way to get it as affordably as possible. And what is the contracting term and structure that you think might work for Guam?
Both are certainly options. You could go either way, and to some extent it probably will also depend on which option you end up going with in terms of land terminal or an FSRU. There are a few companies that you will be working with on the FSRU side, and probably it will be different companies if you're working on the land-based terminal. So you do have a range of options in front of you, and it's just a question of determining the scope and the flexibility also that you would like to have. Would you rather be receiving a cargo once every 2 months, which would require probably more storage, or would you rather be receiving cargoes every 2 weeks, which would be more frequent, but it will be requiring less storage on your end? So. Right. Yeah, that's true as well. Yeah, absolutely.
Yeah, inventory cost. Sir.
I just wanted to say thank you so much to John, Cruz, and as well as the crew at GPA for really being a pioneer in thinking about this and showing us the evolution since 2008 to 2014 as to where we are headed in terms of our consumption here on Guam. And because of the emphasis on the natural gas, I can't help but feel like a mule still. And as a consumer, because the question that I have is, what happens when natural gas runs out? What happens, and I'm sure that you can't answer that question until beyond 2020, but as an island, we need to teach our people how to be independent as opposed to dependent upon price and consumers beyond the shores of Guam. We're still importing gas. We're still importing instead of really living within our means. And so the question that I'm having to ask myself as a leader of a new generation is to say to myself, if this is the emphasis that we're going to go with GPA, then where does that leave us in terms of the ordered dump situation? Because we haven't talked about the ordered dump situation, the natural gas that's already being emitted from that dump. Are we taking into consideration digging up the power poles on this island finally and putting them into the ground where they belong as a typhoon and a natural disaster place? See, I'm trying to think beyond 2020, beyond the natural resources that are going to be imported to the island. And I would suggest that we move into 100% renewable energy on this island, or some diversification in terms of natural resources found on the island. And lastly, is that we're still thinking in isolation, meaning to say, and I asked Ken Flores earlier in the day, how are we thinking as a region instead of just Guam? Because that's the question, right? Whatever happens to Guam happens to the outer islands. And so we are not thinking as a region to promote sustainability. And we're still going this concept of being a mule and dependent upon companies that are foreign to Guam.
50 years from now, We may have OTEC. It depends upon what new technologies develop and the commercial availability and of things like OTEC. In the 2008 IRP, we had people from the OTEC space, and essentially what it ended up was you would have to have heavy subsidization before it would even make sense, and there were no large systems that were in commercial operation. And even those systems that they're talking about in terms of 10 megawatts, $100 million, 100 megawatts, $1 billion. So you know, as planners and as leaders, you need to keep abreast of the developments that are happening in technology in order to get ahead of the curve and to do your thinking. So by the time 2050 comes around, right, you may see 100% renewables, but it may not be in the form that we have today, as in PV and wind power. It might be totally something else. So the best that we can do to answer your question is that we're dedicated to learning and to applying that learning into the planning process and into the political process to get things done. Right? This IRP, this integrated resource planning, it doesn't happen every 2 years. As 2 years or so, or 4 years or so, we get a report. Right? That thinking exists every single day as we take a look at the situation on the ground and things that are developing. Okay? And in terms of thinking regionally, you know, Guam Power Authority, you know, Kin has spoken to people in the region. He is the chairman of the Pacific Power Association, and as such, he is one of the thought leaders in that organization. So a lot of the things that we do learn in our own isolated studies, we share. We've had a group from Tonga who came over several months ago, and they were thinking of doing 100% renewables, but they have like $1 a kilowatt hour. Okay, so based on $1 per kilowatt hour, they would talk. We brought them along in terms of here's what we're doing for batteries, here's what we're doing for wind and PV. Right, so we do get to share those. I speak regularly with friends in the CNMI. My sister, Gloria, happens to manage the Marianas Resort there. And so I get to write up testimony for her on, for free regarding their energy issues with the CUC. We speak to the consultant who's a consultant for CUC. And he's very keen as to what Guam is doing. If Guam can get gas, CNMI will be using gas as a matter of course. So what we do here actually affects a large portion of our regional community.
But here's my thinking behind that, Mr. Cruz. Can't we do a joint RFP to get these solar panels? If we get in the entire region of Micronesia or beyond Micronesia, see? And get exemptions to the Jones Act for this RFP to get these solar panels down so it's very affordable for families in the islands. That's what I'm saying, is that can we think beyond what we have been given so that we can really look strategically as a region so that CNMI can join in this, Palau, FSM, Marshalls. You know,
actually, Palau has
John?
a bunch
it's a
of
give,
PV.
that's it.
Palau actually has a bunch of PV that they're planning on putting in.
John? Sorry,
and their cost points are 45-50 cents a kilowatt hour. They're looking at contracts to supply a PPA to supply them with renewable energy and PV.
John,
Yes?
we have a question over here to the left. I think you might know this
Yeah, it's my
gentleman,
boss.
Mr. Flores.
Actually, Biliana and Doug, we've been struggling with the idea of how much risk should Guam Power Authority or the community absorb in peeling back the layers of the onion. Where, you know, do we own the gasification facility? Do we own the pipelines? Do we own the ships? Do we own the FSRU? And so there's been a lot of mixed signals from wherever all the experts say, okay, in order for you to make it affordable because your volumes, because of your frequencies of delivery, where do you stop peeling back the onion and say, okay, that's the amount of risk that we want to take on and the amount of risk that we want to pass on. And that so be it. Whatever those prices are, then we would live with that. That's my first part of the question. Either Doug or Biliana, if you can share that with me. And then the other question I had was very interesting. I met a gentleman from the U.S. Department of Commerce at the, Jay Merrill was volunteered me to speak on the IRP at the Conference of Micronesian Empowerment. Jay, did I get that right? Close enough. But I met this gentleman indicating to me that the Native Americans, Native American Indians, Pacific Islanders, Hawaiians, are sitting on one of the largest finds of LNG or natural gas in the nation, U.S. nation, and that they're trying to get that out and promote that from point A to point B, such as islands of Guam. They want to develop that with in an expedited fashion. You know, Indian reservations, they have their own casinos, they're exempt from many tax laws, et cetera, et cetera. They're treated with indigenous rights within their sovereignty. So can you speak to that about what do you know about that market that's emerging, or is it going to happen very soon that we can take advantage of the Native American gas finds and delivery and development to Guam, Hawaii, and maybe our neighboring islands with the CNMI? And so with that, I leave you those two questions for discussion and or comment. Thanks.
Well, as regards to your second question, Ken, we're working in Alaska, and Alaska's been sitting on large volumes of natural gas for many years, and they're beginning to move forward with freeing up those reserves, and but it's got a long way to go. The best estimates now are that in Alaska, you won't be seeing those supplies hitting the market until mid 2020 or something like that. And I would think that similar things would probably be true with these Native American finds that we're not familiar with that you just referenced. That I'm not sure those would be something to be available to Guam, in the current planning horizon. So perhaps a more near-term solution is something to be looked at here rather than something that maybe that will come into play later on.
Mm-hmm.
I'd like to speak to the first question.
Sure.
First question about risk. A lot of people will tell us a lot of different things depending upon what part of the industry they have in terms of their perspective on our risk. But bringing as many people to the table to discuss those, it's up to us to. It's up to Ken Flores and his group to adjudicate which risks that the utility is willing to take up. And that's really maybe even at the policy level something for the CCU and the PUC and to take up. Because, you're right. You'll hear one thing from one person and another thing from another person, and pretty soon your head spins. But if you get all of those interests, and hopefully the PMO will help us herd the cats, right, and help us weigh all of those different inputs, right, we can make the best decision, because it's ultimately up to us.
I would just offer a perspective on the choice of owning versus chartering a vessel or FSRU. Just looking at what the other countries are doing, Argentina is one example where they're using FSRUs for their import facilities. They're also actually actively trying to develop their own shale gas, which they have a lot of. And just watching how they have made their decisions. An FSRU, you could buy it if you wanted to, but you could charter it. It just gives you a lot more flexibility and optionality. And especially when you're talking about infrastructure that ties you to a particular market that can be unpredictable. We've had drastic changes in the costs, right? It gives you a flexibility where you could shift your direction in a relatively easier way than if you were to build something on land that requires more physical, concrete things in the ground. That's much more difficult to change. And we've seen that work like that also in the U.S. With the regas facilities we have. There is an FSRU facility up in the Northeast that has that flexibility. Those ships actually can move as well. So you could disassemble them, move them, put them somewhere else. Potentially that an FSRU could be something that you could be sharing with different islands along the chain. Rather than building something in one spot that's really tied to the island and makes your plans a lot less flexible in the future.
Okay. We've got one more question from Mr. John Robinson.
Yes, for Doug. You mentioned Hotel Wharf as a potential site. Could that site be used also for a shore-based facility? And one reason I'm asking is because if you have a floating facility, such as that, as you mentioned, in case of a typhoon, most floating vessels have to put out to sea for a few days. So we would have a gap in supply, supposedly. And also, floating vessels have to go into dry dock occasionally, which would take it out of service for some period of time. So it appears a shore-based facility might be a better option, but you've been studying the situation a lot more. Thank you.
No, you're right. An FSRU might have to get moved out of the harbor in case of a typhoon or some other event. We have identified for GPA a solution to mitigate that, which would be to establish a small storage tank. Not small, almost 7 million gallons of LNG that would provide a week's worth of storage, which in theory would be enough time to get the FSRU out of the harbor, have the typhoon go through, and then bring the FSRU back in. There isn't enough space at Hotel Wharf for a land-based facility. But that's certainly one of the trade-offs that needs to be looked at moving forward here. Having a land-based facility that would survive a typhoon and continue to operate, or at least operate shortly thereafter, versus an FSRU that might have to get moved out of the harbor for a typhoon or some other MARSEC event where the captain of the port orders the ship out.
Okay. How about a round of applause for the panelists? Okay, don't go away. We still